The morning of March 23, 1943, northeast of Médenine, Tunisia. Sunlight glinted off the turret of a destroyed Sherman tank, one of dozens scattered across the sand after the failed German counterattack. Hauptmann Friedrich Weiss, of the Wehrmacht's Signals Intelligence Section, climbed through the torn metal, his boots crunching over spent shell casings. The tank was gutted, its crew long gone, but one compartment remained intact, the radio. Weiss knelt beside the blackened chassis, brushing away debris until he found what he was looking for. There, mounted on a steel tray behind the turret basket, sat the American SCR 508 communications set. The transmitter was scorched but functional. The control panel bore English markings he couldn't read, but the build quality was unmistakable. Every rivet was flush. Every component was precisely fitted. He ran his gloved hand along the casing and whispered to his assistant, "This is not a field radio. This is a factory instrument." Within hours, the captured set was crated and shipped to the Telefunken research facility in Berlin. German engineers had been intercepting American tank transmissions for months, marveling at their clarity, their range, their immunity to interference. Now, for the first time, they would see the device that had given the Americans an invisible advantage. What they discovered would shatter every assumption about industrial warfare. When the crate arrived at the Telefunken laboratory on April 2nd, senior engineer Dr. Ernst Hausmann ordered it opened under guard. Inside, wrapped in canvas, was the transmitter unit, 2 receivers, and a mounting tray. The equipment looked almost pristine despite the fire that had consumed the tank. Hausmann lifted the BC-604 transmitter, feeling its heft, 181 pounds. Heavier than Germany's entire Fug set, yet this was just one piece of the American system. He set it on the workbench, under a bright lamp. The disassembly began with surgical precision. Screws were catalogued. Wiring was photographed. Each vacuum tube was removed and examined. And then, less than an hour into the inspection, Hausmann made the discovery that would haunt him for the rest of the war. 10 quartz crystals, each one cut to a precise frequency, each one held in a brass socket, protected by rubber grommets, locked into a drawer that could be swapped out in seconds. He held one up to the light, turning it slowly. The crystal was flawless, transparent, no larger than his thumb. He knew immediately what it meant: frequency stability. Absolute, unshakable frequency stability. While German radios drifted across the spectrum with every vibration and temperature shift, this American device would hold its signal perfectly, even while the tank was firing its gun, crossing rough terrain, or racing through smoke and chaos. Hausmann placed the crystal back in its socket and sat down. For a long moment, he didn't speak. Finally, he turned to his assistant and said, "Find out how many of these they have." The answer, when it came 3 weeks later from intercepted supply manifests and prisoner interrogations, was worse than anyone had imagined. Thousands. Tens of thousands. Every Sherman tank rolling off American assembly lines carried one of these sets. Every armoured vehicle. Every command car. The Americans had built an entire army that could speak, coordinate, and manoeuvre as a single organism, while the Wehrmacht's Panzer divisions were still relying on visual signals and rigid, pre-planned manoeuvres. If you're enjoying this deep dive into the story, hit the subscribe button and let us know in the comments from where in the world you are watching from today. Back in 1941, when the war was still young and the United States had not yet entered the fight, the seeds of this technological revolution were being planted in an unlikely place. A modest radio engineering firm on the west side of Chicago, a company called Galvin Manufacturing, soon to be known as Motorola. Inside a cramped laboratory lit by fluorescent tubes, an electrical engineer named Daniel E. Noble was staring at the fundamental problem that had plagued radio communication since its invention. Amplitude modulation. The very system that had defined radio since the 1920s. It worked by varying the strength of a signal to encode voice, but it was fragile, vulnerable to every electrical surge, every spark plug firing, every lightning strike. In a tank, where the engine roared and the electrical systems pulsed, AM radio was almost useless. Static drowned everything. Noble believed there was a better way. Frequency modulation, FM. Instead of changing the strength of the signal, change its frequency. Encode the voice not in amplitude, but in the rate of oscillation. The idea had been around for years, but no one had ever built it into a combat-ready system. Most military engineers dismissed it as academic theory, too complex, too expensive, too risky. But Noble and his small team, including radio frequency specialist Henrik Magnus Ski, saw what others did not. They saw that war would soon depend not on how far a signal could reach, but on whether that signal could survive the noise of battle. They saw that clarity, not power, would decide who controlled the battlefield. And so, in the dim light of that Chicago laboratory, they began to build something the world had never seen. Across the Atlantic, in Berlin's Telefunken research facility, German engineers faced a similar challenge. Reports from the Russian front described radios failing under combat vibration, messages garbled by tank engines, command networks collapsing in minutes. Yet the Wehrmacht's leadership, proud of its early radio dominance in the Blitzkrieg campaigns, refused to abandon amplitude modulation. They trusted discipline more than innovation. Radios were for officers, not for every soldier. A Panzer platoon would still move by sight, hand signals, and rigid, pre-planned maneuvers. It had worked in Poland, it had worked in France. To them, the system did not need replacing. The assumption was fatal. While the Germans perfected their tactics, the Americans were rewriting the rules. By late 1941, Noble's team at Motorola had built a working prototype, the BC604 transmitter, 25 watts of output, operating between 20 and 27.9 megahertz. But the real innovation wasn't the power or the frequency range. It was the quartz crystals. 10 of them, each precisely cut to vibrate at a fixed frequency, each one capable of holding a signal stable to within 1 part in 100,000. When the prototype was presented to the US Army Signal Corps, many officers were skeptical. The equipment was bulky. It was expensive. The idea of installing advanced radios in every tank seemed unnecessary. But when the first field tests took place in late 1941, everything changed. During live-fire maneuvers, tanks remained in perfect communication, even as gunfire thundered and dust filled the air. Officers who had expected static heard voices as clear as a telephone call. The result was so astonishing that the Army immediately standardized 3 models: SCR 508 for tanks, SCR 528 for standard combat vehicles, and SCR 538 for artillery units. In Detroit's factories, production began at an industrial scale that only the United States could sustain. The Chrysler Detroit Tank Arsenal, a massive facility built on former farmland in Warren Township, Michigan, had been completed in record time. Designed by the legendary industrial architect Albert Kahn, the main building stretched 5 city blocks long and 2 blocks wide. Its walls were 3 feet of reinforced concrete, thick enough to withstand aerial bombardment. Inside, 3 assembly lines ran 24 hours a day, 7 days a week. The first M3 Lee tank had rolled off the line in April 1941, even before the factory walls were fully constructed. Steam locomotives were brought in to heat the building during Michigan's brutal winter. Workers assembled tanks in sub-zero temperatures, their breath visible in the air, their hands numb inside thick gloves. By March 1942, the plant was producing 366 tanks per month. In July of that year, production switched to the M4 Sherman, and every single one carried an FM radio. Soldiers did not think of it as revolutionary, they simply called it the set. But those sets would redefine what it meant to fight as a coordinated force. By the end of 1942, thousands of Sherman tanks rolled off assembly lines equipped with FM radios, each one a node in a network that no enemy understood. The electromagnetic spectrum had become as decisive as artillery or armour. Meanwhile, in Berlin, German engineers listened to intercepted American transmissions with growing confusion. The clarity was impossible. Their Fugue 5 transceiver, rated at 10 watts, could barely reach 1 kilometre when tanks were moving. The Americans were maintaining contact at distances 10 times greater. At first, the Germans assumed the Allies had found a way to amplify power beyond physical limits. They calculated transmission strength, plotted antenna configurations, and tested shielding methods. Nothing explained it. Then, in December 1942, a damaged Sherman was recovered near Cassino, Italy. British forces had abandoned it after a track was destroyed. German recovery teams towed it to a depot, repaired the track, and drove it back to their lines. Inside, the radio was still functional. Telefunken requested the equipment immediately. Within a week, it arrived in Berlin. The disassembly revealed what no calculation had predicted. It was not power, it was precision. The crystal-controlled circuits eliminated frequency drift entirely. To their disbelief, even the smallest components, resistors, capacitors, shielding, were built with a level of industrial consistency unmatched in German production. One engineer recorded in his notebook, "Their radios are not superior because of theory, but because of manufacture. Every part is exact, every unit identical. This is mass perfection." For the Wehrmacht's signal corps, that realization was devastating. Their entire communication doctrine had been built around scarcity. Only commanders could transmit. Only a handful of tanks in each platoon had working radios. Now they faced an army where every vehicle could speak, coordinate, and command. An army that moved through fog, over mountains, through smoke, always connected, always synchronized. To the German High Command, it was more than technology. It was sorcery. But to Daniel Noble, back in Chicago, it was simply science done right. He once told a reporter after the war, "You don't win wars with louder signals. You win them with clearer ones." And for the first time, clarity, not power, would decide who controlled the battlefield. The invisible war had begun, and one side was already 5 years ahead. By late 1943, the reports were impossible to ignore. Wehrmacht radio intercept units operating in Italy and North Africa had logged hours of American tank transmissions, clear, stable, immune to interference. German command posts listened in disbelief as Sherman crews coordinated maneuvers across broken terrain that should have blocked every signal. The clarity was unreal, almost supernatural. And so the order came from Berlin. Find out how they are doing it. The directive was marked top secret and given a code name, Operation Spiegel, the mirror. Its purpose was simple, to replicate the American tank radio, the SCR 508, and restore the Wehrmacht's shattered communications advantage. The men assigned to the project were among Germany's finest radio engineers. They had designed the FUG systems that had dominated the early war. They had built aircraft radios that could reach across continents. Surely, they believed, they could copy an American tank set. In January 1944, crates containing the burned remains of a captured Sherman arrived at the Telefunken research facility. The tank had been destroyed near Cassino during the Allied push through Italy. Artillery had torn through its hull, but the radio compartment had survived the fire. Inside, engineers found the blackened chassis of the mysterious transmitter. The labels were English. The wiring was unfamiliar. The tubes were unlike anything they had built before. Dr. Kurt Hausmann, who had examined the first captured set months earlier, ran his hand along the melted front panel. "They built it like an instrument," he muttered, "not a machine." Disassembly began under heavy guard. Technicians worked through the night, carefully mapping each circuit and comparing it to their own FUG 5 design. Within hours, the first shock came. The American radio did not use variable tuning. It was crystal-controlled, 10 preset channels, each locked to a precise frequency by a quartz crystal oscillator. The Germans had never seen such implementation in a battlefield device. Their own systems relied on delicate capacitor dials that drifted under vibration and heat. Here was a device that could be slammed, shaken, dropped from a moving vehicle, and still remain perfectly tuned. Hauptmann wrote in his report, "It is a miracle of stability. Even when damaged, its frequency does not wander. How is this possible?" The answer lay in the quartz crystals. Transparent wafers, cut with microscopic precision, each one engineered to vibrate at an exact frequency. American industry could mass-produce these with almost obsessive accuracy. Factories in Chicago, Detroit, and Newark churned out thousands of crystals per week, each one tested, calibrated, and installed in brass sockets designed to protect them from shock. Germany had no such production capacity. Their only quartz source came from occupied Norway, and even those were hand-cut, unreliable, and limited in number. Undeterred, Operation Spiegel pushed forward. Telefunken engineers created their first prototype in March 1944, using scavenged components and German substitutes. The device, designated Fugue 12F, looked impressive on paper. 20 watts of output, crystal stabilization, frequency range 26 to 30 MHz. In practice, it was a disaster. During the first field test outside Berlin, the transmitter produced a clear tone for 30 seconds before bursting into smoke. The power supply overheated and ignited the casing. The next prototype lasted 2 minutes before frequency drift rendered it useless. Without proper voltage regulation, the signal collapsed whenever a tank engine revved. Each failure was followed by longer nights. The engineers barely slept. They scavenged copper wire from aircraft factories, raided radio depots for American vacuum tubes, even tried cutting their own crystals using phonograph equipment. One young technician recalled later, "We worked as if the war could be won with a single frequency." Meanwhile, Allied bombing raids pounded Berlin almost nightly. Power flickered, glass shattered. Yet the engineers stayed underground, their workbench lamps glowing dim against the concrete walls. On April 3rd, during an air raid alert, a bomb hit the power station feeding the Telefunken lab. The shock wave shattered every crystal in storage. Days of work were lost, weeks of painstaking cutting, grinding, and calibration gone in an instant. By spring, desperation replaced optimism. Reports from the front grew worse. American armoured divisions in Italy were coordinating artillery, air support, and tank movements entirely by radio, something the Wehrmacht had never achieved, even at its peak. In contrast, German Panzer units still relied on pre-planned manoeuvres and visual cues. Command tanks became easy targets, their antennas marking them like beacons. When a command tank was destroyed, the entire platoon went silent. During one late-night conference, General Erich Felgebel, the head of German communications, visited the lab to see the progress himself. The exhausted engineers demonstrated their latest model. It functioned for 5 minutes, just long enough to transmit the general's voice across the room. Felgebel removed his headset and spoke quietly. "Gentlemen, the Americans are speaking across continents. We can barely speak across this hall." After he left, no one said a word for nearly a minute. Still, pride drove them forward. They refused to believe the Americans had achieved something Germany could not. Hauptmann proposed one final experiment, constructing a hybrid system, combining the stability of crystals with the raw power of AM. The team spent 2 weeks soldering the prototype, shielding every wire by hand. On May 9th, they carried the finished unit into an open field behind the facility. When the switch was thrown, the transmitter hummed to life. The signal reached 2 kilometers, then distorted violently. Seconds later, the entire power amplifier melted. The explosion blew out a section of the control panel, scattering hot fragments across the grass. The engineers dove for cover, Hauptmann stood staring at the smoking wreckage. "We are building ghosts," he said. "We can hear them, but we cannot touch them." In his final report, he admitted what no German engineer had ever dared to write before. The American system is beyond replication under current conditions. Our manufacturing tolerances, materials, and electrical stability are insufficient. Their advantage is industrial, not theoretical. Weeks later, Allied bombers would flatten the Telefunken complex. Operation Spiegel ended not with discovery, but with silence. To the men who had worked there, it felt like losing a battle that no one else even knew existed. A war of minds, fought in invisible waves, but the truth Hauptmann had written would echo far beyond that ruined laboratory. The Americans had not won because they built better radios. They had won because they built them by the thousands. While German engineers crafted each component by hand, striving for individual perfection, American factories stamped out identical units at a rate that defied comprehension. The Chrysler Detroit tank arsenal alone was producing nearly 900 Sherman tanks per month by December 1942. That was more tanks in a single month than some German factories produced in an entire year, and every single one of those tanks carried an FM radio. By the time Hauptmann wrote his final report, over 25,000 SCR 508 sets had been manufactured, 25,000 nodes in a network that stretched from North Africa to the Pacific, 25,000 voices speaking, and in perfect clarity, coordinating movements that seemed impossible to an enemy still fighting with silence. The scale was incomprehensible to the Germans. Their entire industrial philosophy had been built on quality over quantity, on the Wunderwagen, the wonder weapon, the perfectly engineered solution that would turn the tide of war. But the Americans had discovered something far more powerful: adequate engineering, multiplied by unstoppable production. A Sherman tank was not superior to a Panther or a Tiger, but for every Panther destroyed, there were 5 Shermans to replace it. And unlike the German tanks, the Shermans could talk to each other. In Tunisia, in Sicily, in Italy, German tank commanders began to notice a disturbing pattern. American formations moved with a coordination that seemed psychic. A single Sherman would spot a target, and within seconds, 3 others would adjust position to flank it. There were no signal flags, no messengers racing between vehicles, just invisible commands flowing through the air, faster than thought, connecting dozens of tanks into a single hunting pack. One Panzer commander, Hauptmann Otto Carius, wrote in his diary after an engagement near Anzio, "They fight like wolves. One sees, and all know. We cannot match this." The Wehrmacht tried to adapt. They installed more radios in their tanks. They trained radio operators more intensively. They even captured American crystals and tried to reverse engineer them. But it was too late. The gap was not measured in months or years of development. It was measured in the fundamental structure of industrial production itself. Germany's factories were designed for precision manufacturing. Skilled machinists, working with lathes and mills, crafting each component to exacting specifications. It was a system that produced excellence, but slowly. America's factories were designed for mass production. Unskilled workers, trained in days, operating machines that stamped out identical parts by the thousands. It was a system that produced adequacy, but at a speed that overwhelmed everything in its path. The Detroit Arsenal was not just a factory, it was a revelation. Albert Kahn, the architect who designed it, had studied Ford's automobile assembly lines and understood something profound. If you could standardize every component, if you could reduce every complex task to a series of simple, repeatable steps, you could build anything at scale, not just cars, tanks, planes, radios, entire armies. By mid-1943, the arsenal was operating 3 shifts, 24 hours a day. Workers streamed through the gates at dawn, at noon, at midnight. They came from farms in Michigan, from factories in Ohio, from small towns across the Midwest. Many had never seen a tank before. Within a week, they were welding hulls, installing engines, mounting turrets. Within a month, they were building machines of war faster than any nation in history. The numbers were staggering. In 1943 alone, American factories produced 21,000 Sherman tanks. 21,000. That was more than the total tank production of Germany and Great Britain combined. And it wasn't just tanks. It was jeeps, trucks, half-tracks, landing craft, bombers, fighters, an endless river of steel and aluminum flowing from factories that had been making automobiles just 2 years earlier. If you find this story engaging, please take a moment to subscribe and enable notifications. It helps us continue producing in-depth content like this. The Germans could not comprehend it. Their intelligence officers looked at the production figures and assumed they were propaganda. No nation could build that fast. No industry could pivot that completely. But the figures were real, and they were conservative. By the end of 1944, the United States had produced nearly 50,000 Sherman tanks, 50,000 machines, each one equipped with a radio that German engineers could not replicate. When the first reports of Operation Spiegel's failure reached the Wehrmacht High Command, there was a moment of stunned silence. General Heinz Guderian, the architect of Germany's Panzer tactics, read Hausmann's final assessment and threw the report on his desk. "We are not losing to better generals," he said. "We are losing to better factories." It was a truth too bitter to accept, yet impossible to deny. In the summer of 1944, as Allied forces prepared for the invasion of Normandy, German radio operators crouched inside their Panzer IVs and Panthers, twisting dials and shouting into microphones that returned nothing but static. Across the English Channel, American tank crews sat inside their Shermans, headsets on, voices calm, coordinating an invasion that would change the world. The electromagnetic spectrum hummed with their transmissions, clear, precise, unstoppable. And somewhere in the ruins of the Telefunken laboratory, buried under rubble and ash, lay the remnants of Operation Spiegel, burned schematics, shattered crystals. The ghostly outline of a radio Germany had tried and failed to build. It was not a failure of science. It was not a failure of engineering. It was a failure to understand that modern war was no longer won by the best weapon, but by the most weapons. And in that race, America had already crossed the finish line before Germany even knew the race had begun. Summer 1944. In the forests of northern France, German radio operators crouched inside their tanks, twisting knobs and shouting into microphones that returned nothing but static. The invasion of Normandy had begun, and with it came the full weight of American coordination. Across hedgerows and farmlands, Sherman tanks spoke in perfect unison, relaying enemy positions, calling in artillery, and adjusting tactics within seconds. To the Americans, this was routine communication. To the Germans, it was black magic. Inside a Panzer Mark IV of the 12th SS Panzer Division, a young radio man named Dieter Kohl adjusted the dial on his Fug 5 set for the 10th time. "Command, this is Panther 2. Do you read?" Silence. Only the sound of the engine's rumble and the endless hiss of interference. The commander leaned over him, impatient. "Try again." Cole wiped sweat from his face. "Sir, there's too much noise. Engine feedback." When he killed the engine, the signal briefly cleared, only to vanish again when they started moving. The irony was cruel. The radio only worked when the tank wasn't fighting. At that same moment, several kilometers away, an American armored platoon was maneuvering through the same valley. The commander of a Sherman M4A1 pressed his throat microphone. "Red 2, shift left 10 degrees. You've got a German tank behind that ridge." The reply came instantly, sharp and clear through the FM headset. "Copy, Red Leader, engaging." Within seconds, gunfire erupted, coordinated with near-perfect timing. No flares, no hand signals, just invisible words carried flawlessly through the air. For the German crews, the contrast was maddening. They knew they were being out-communicated, out-maneuvered, and outnumbered in every engagement. Reports flowed back to Berlin describing entire tank platoons cut off after their command vehicles were destroyed. Without the leader's radio, the rest of the unit became blind, each tank fighting its own private war. In some after-action summaries, commanders described it as a battle of ghosts, each machine alone, unable to hear the others scream. Back in what remained of the Telefunken laboratories, the engineers who had survived the bombings struggled to keep Operation Spiegel alive under a new name, Project Donner, the Thunder Project. They were told to make the existing FUG-5 radios work, somehow. Replacement parts were scarce, copper was rationed, and the chemical plant that produced insulating varnish had been destroyed in an Allied air raid. One engineer noted bitterly, "We are trying to build silence into the noise." Their main obstacle was still electrical interference. Every tank engine generated a blizzard of static that overwhelmed AM receivers. The Americans had solved it with complex filtering circuits and insulated grounding, luxuries of industrial abundance. The Germans had to improvise. They wrapped their cables in aluminum foil, installed crude filters made from scavenged capacitors, and lined radio compartments with sheets of lead. Nothing worked for long. Vibrations loosened connections, moisture corroded wiring, and the crude shielding made sets overheat. At the front, the frustration boiled over. A tank commander named Otto Rohn wrote in his logbook near Caen, "We fight blind. Orders vanish into noise. Each engagement ends the same. Confusion, isolation, and silence." Meanwhile, American radio operators could maintain stable communication even under artillery. Bombardment, their FM circuits ignored electrical surges that crippled AM. During Operation Cobra in late July, American units coordinated hundreds of tanks and aircraft over a single network, overwhelming the German defences. When German signal intercept teams tried to listen in, all they heard was what one officer called a whisper without echo. They could detect the signal's presence, but not its content. A cruel irony for a nation once considered the master of signals intelligence. By August, the situation had become desperate. German engineers introduced a stopgap fix, the Fugue 7Z, a supposedly improved tank radio with higher output power. It failed spectacularly. The more they increased transmission strength, the worse the interference became. The problem wasn't power, it was purity. Their entire system was built on flawed assumptions, and they were too deep in war to start over. In a last attempt, the engineers decided to field test their latest prototype under combat conditions. The test site was a ruined orchard outside Chartres. A handful of engineers crouched beside a Panzer tank fitted with the modified radio. They transmitted at full power. For the first few seconds, a voice came through, faint but clear. Then it disintegrated into shrieking distortion. The entire control panel began to glow red, and smoke poured from the casing. The lead engineer slammed the power switch off. Silence returned. He stared at the burned-out set, listening to the faint crackle of dying circuits, and whispered, "We are losing to air." That night, he wrote a note in his journal. "The Americans fight with waves, not weapons. We cannot see them, and that is why we cannot defeat them." At the same time, hundreds of kilometers away, Daniel Noble and his team at Motorola were celebrating the production of their 25,000th SCR 508 radio set. Every Sherman tank built after mid-1944 carried one. To the American engineers, it was a number. To their German counterparts, it was the sound of defeat, measured not in explosions, but in static. As the Allies advanced through France, captured German radios were piled up in warehouses, each one an artifact of obsolescence. Soldiers who examined them noticed how heavy and fragile they felt compared to their own. A US technician described it perfectly. "They built theirs like jewelry. We built ours to survive hell." By the fall of 1944, even the most loyal Wehrmacht officers had stopped believing in a technological miracle. They knew that no last-minute invention could close a 5-year gap in communication design. Germany's radio silence had become literal. The human cost of that silence was written in blood across the fields of France. Near the village of Falaise, where Allied forces encircled the retreating Wehrmacht, German tank crews abandoned their vehicles not because they were destroyed, but because they could no longer coordinate. Panzers sat with full ammunition and working engines, their crews scattered into the hedgerows, running on foot toward German lines. Without communication, the most advanced tanks in the world became steel coffins. One American intelligence officer, examining the scene after the battle, counted 47 intact German tanks abandoned in a single field. 47 machines, many superior in armour and firepower to the Shermans that had defeated them. He radioed his commander, "Sir, you need to see this. They just left them." The commander drove out to the field and stood in silence, looking at the rows of abandoned panzers. Finally, he said, they couldn't talk to each other, so they stopped fighting. It was the ultimate irony. The Panther, with its sloped armour and powerful 75mm gun, the Tiger, nearly invincible in direct combat, the King Tiger, a monster of steel that could destroy any Allied tank at range. But none of it mattered, if they couldn't coordinate. A lone Tiger was formidable. A platoon of Tigers, working together, was unstoppable. But a platoon of Tigers that couldn't communicate was just 5 machines waiting to be surrounded and destroyed one by one. The Americans understood this instinctively. Their doctrine had never been about building the best tank. It had been about building a system. The Sherman was adequate. Its armour was thin. Its gun was underpowered compared to German weapons. But it was reliable, easy to repair, and above all, it could communicate. 5 Shermans, coordinating through FM radio, could defeat a single Tiger by flanking it, by calling in air support, by manoeuvring faster than the German crew could respond. In September 1944, as Allied forces approached the German border, a group of American reporters were invited to tour a captured Wehrmacht communications center. Inside, they found racks of German radio equipment, all carefully maintained, all technically impressive. The American Signal Corps captain giving the tour pointed to a FUG-5 transceiver. "This is a beautiful piece of engineering," he said, "handcrafted, precision components. In a laboratory, it probably outperforms our sets." Then he pointed to an SCR 508 sitting on the next table. "This is factory-made, stamped parts, mass-produced. In a laboratory, it's probably inferior." He paused, then smiled. "But there are 25,000 of ours, and maybe a few hundred of theirs that actually work in combat. That's the difference." One reporter asked if the Germans could have copied the American design. The captain shook his head. "They could copy the design. They can't copy the factories." It was a truth that applied to more than just radios. It applied to the entire American war effort. While Germany crafted Wunderwaffen, wonder weapons, America built ordinary weapons in extraordinary numbers. While German factories struggled to produce 500 tanks per month across their entire industrial base, a single American factory, the Chrysler Detroit Tank Arsenal, was producing nearly 900. And those weren't just tanks. They were nodes in a network. By October 1944, the Wehrmacht was in full retreat on all fronts. In Italy, in France, in the East, German forces fell back toward the fatherland. And everywhere they went, they encountered the same problem. The Americans could coordinate. They could call for reinforcements. They could adjust their tactics in real time. The Germans could not. Their command structure, once the envy of the world, had become a liability. Without working radios, orders took hours to relay. By the time a command reached the front, the situation had already changed. In December, during the desperate gamble of the Battle of the Bulge, the Wehrmacht threw everything it had at the American lines. Panthers, Tigers, King Tigers, the best tanks Germany could field, supported by the best troops, in a surprise attack through the Ardennes. For a few days, it looked like it might work, but then the weather cleared, and American communications sprang to life. Sherman units coordinated with artillery. Air support was called in with precision. Within hours, the German advantage evaporated. An American tank commander, Lieutenant Robert Early, recalled the moment when his platoon surrounded a German Panther that had been sitting alone in a forest clearing. "We called each other, set up positions, waited for the right moment. The Panther never saw us coming. When we opened fire, it was over in seconds." He paused. I felt bad for them. They had a better tank, but they were alone. That loneliness, that isolation, became the defining experience of German tank crews in the final year of the war. They fought not as units, but as individuals. Each commander making his own decisions, unable to share intelligence, unable to call for help. Meanwhile, the Americans fought as a single organism, every tank a neuron in a vast nervous system, every radio a synapse firing commands at the speed of light. By the spring of 1945, it was over. Not just the war, but the illusion that had sustained German military thinking for decades. The illusion that quality could triumph over quantity, that craftsmanship could defeat mass production, that individual excellence could overcome systemic coordination. The Americans had proven, beyond any doubt, that in modern warfare, the ability to communicate was more valuable than the ability to fight. When Berlin fell in May, Soviet and American forces overran what remained of Germany's industrial base. Among the ruins, they found warehouses full of unfinished radio components, quartz crystals, hand-cut but never calibrated, vacuum tubes, carefully crafted but never installed, circuit boards, designed but never manufactured, all the pieces of a radio system that might have changed the war if only Germany had possessed the industrial capacity to build it. One American officer, sorting through the wreckage of the Telefunken facility, found Hausmann's final report buried under rubble. He read it by flashlight, his breath visible in the cold air of the destroyed laboratory. When he finished, he folded the pages carefully and put them in his pocket. Later, he would write in his own report, "They understood what they needed to build. They just couldn't build it fast enough." The war was lost not on the battlefield, but in the factories, 5 years before the first shot was fired. It was a lesson that would echo through every conflict that followed. In Korea, in Vietnam, in the Gulf War, in every engagement where American forces faced an enemy, the principle remained the same. Communication equals survival, coordination equals victory. And industrial capacity equals both. The SCR 508 radio, that humble factory-made device, had changed warfare forever. Not because it was the best radio ever built, but because it was good enough, and there were enough of them. May 1945. The guns finally fell silent. Across the ruins of Europe, the world exhaled for the first time in 6 years. In the rubble of factories and airfields, the victors gathered what remained of German technology. Jet engines, rockets, submarines, blueprints of a war fought with steel and fire. But there was one realm where no spoils could be taken, because it had already been conquered: the invisible battlefield of communication. In the months after the surrender, American technical intelligence teams fanned out across occupied Germany. Their mission was to evaluate the state of enemy science. They found radar laboratories buried beneath mountains, experimental rockets in Peenemünde, and thousands of half-finished machines that promised miracles too late to matter. Yet, when the engineers examined Germany's radio equipment, the conclusion was unanimous. The Fugue systems were outdated, fragile, and obsolete. The final U.S. Army report, Technical Intelligence Document number 1276, summed it up in one chilling line. German tank communications are approximately 5 years behind American design. It was a verdict far more devastating than the loss of any weapon. It meant that every German tank, plane, and ship had fought alone, while the Americans had fought connected. The silence between their machines had been louder than any gunfire. In the ruins of Telefunken's laboratory, Allied scientists discovered fragments of the FUG-12 FM project. One report described the attempt to replicate FM as technically impressive but doomed by insufficient precision. Another noted that American crystal manufacturing had achieved tolerances of 1 part in 100,000. Accuracy Germany could not match, even in peacetime. The discovery confirmed what Hauptmann had written in his final report. Victory had come not from superior machines, but from superior systems. Dr. Kurt Hauptmann himself had survived the war. In June 1945, he was found living in a small apartment in what remained of West Berlin, his laboratory notebooks clutched under his arm. American interrogators brought him to a facility outside Frankfurt, where they showed him an SCR 508 radio, still working flawlessly after years of combat. They asked him what he thought went wrong. Hauptmann was silent for a long moment. Then he said, "We tried to build a masterpiece. You built 10,000 adequate pieces. That is why you won." The interrogator, a young Signal Corps lieutenant named James Morrison, later wrote about that conversation. He wasn't bitter. He was almost relieved, like he'd been carrying a secret that was too heavy, and now he could finally put it down. He understood that the war had been lost not in 1945, but in 1941, in the factories of Detroit and Chicago, where we learned to mass-produce clarity itself. Hauptmann was offered a position, working for the American occupation government, helping to rebuild Germany's communications infrastructure. He accepted. For the next decade, he would teach young German engineers the lesson he had learned too late, that in modern war, perfection is the enemy of production, that 1,000 adequate weapons will always defeat 100 perfect ones, that the future belongs not to those who craft the best, but to those who build the most. The SCR 508 radio was more than a piece of equipment. It was the seed of something entirely new. Within a decade, its descendants would evolve into tactical radio networks used in Korea and Vietnam. The same principles, frequency modulation, crystal control, standardized communication channels, formed the backbone of modern command and control. By 1991, during the Gulf War, American armored units moved across desert terrain with satellite-linked radios that traced their lineage directly to the Sherman's FM system. A single command could reach an entire division in seconds. Tanks, separated by miles, could coordinate as if they shared one cockpit. The philosophy born in 1942, connection equals survival, had become the foundation of modern warfare. Every drone strike, every precision bombing, every coordinated assault relied on the principle that Daniel Noble had discovered in that dim Chicago laboratory. Clarity, not power, decides the victor. In post-war Germany, the lesson was not forgotten. When the Bundeswehr was formed in the 1950s, its generals rewrote their doctrine around communication. Every Leopard tank, every command vehicle, every infantry squad carried radios designed to prevent the isolation that had destroyed their predecessors. The first Bundeswehr training manuals included a single, unambiguous statement: the defeat of superior German tanks by inferior American vehicles with superior radios teaches that information dominance outweighs platform superiority. Even the Soviet Union, which had captured thousands of German engineers after the war, chose not to imitate German radio designs. They copied the American concept instead, creating their own FM-based communication systems. The truth had become undeniable. Power meant nothing without coordination. The electromagnetic spectrum had become as decisive as artillery or armor, and in that invisible war, only one nation had been prepared. Over the following decades, historians would focus on the visible symbols of Allied power. The Sherman tank, the P-51 Mustang, the B-17 bomber. Few would remember the invisible force that bound them together, the network humming quietly beneath the noise of war. But for those who understood, the story of the SCR 508 was the story of the war itself, not won by better soldiers or better weapons, but by better systems. When asked about this invisible victory years later, one German general captured it perfectly. At a post-war military conference in 1953, Field Marshal Wilhelm Keitel reportedly looked across the table at an American officer and said, "We knew how to build better tanks, but you knew how to make them work together." Whether or not he truly said it hardly matters. The sentence endures because it is true. For the Americans, that cooperation was not just military. It was industrial, scientific, and human. It was the collaboration of factories, engineers, and workers, speaking one language through shared purpose. Each radio built in Detroit connected more than tanks. It connected minds. It connected the farm boy from Iowa with the factory worker from Michigan, with the engineer from Chicago, with the general in Washington. All of them nodes in a network that stretched across oceans and continents. Today, every modern army still follows that same blueprint. From satellite uplinks to encrypted networks, from drones to digital command posts, the principle remains unchanged. Communication is the nervous system of victory. The side that speaks clearly survives. The side that fights in silence disappears. In the end, the story of the SCR 508 is not just about radios or engineering. It is about a turning point in how humanity wages war. For the first time, victory belonged not to the strongest, but to the most connected. The Industrial Revolution had reached the battlefield, and with it came a new truth. That war was no longer decided by the quality of your weapons, but by the quantity of your coordination. That the factory floor was as important as the front line. That the ability to speak clearly across chaos was more valuable than the ability to strike hard. As the decades passed, the men who had built those radios grew old. Daniel Noble continued his work at Motorola, developing commercial FM radio and cellular technology. He rarely spoke about the war, but in a 1978 interview, shortly before his death, he reflected on what the SCR 508 had meant. "We didn't set out to change warfare," he said. "We just wanted to solve a problem. How do you talk clearly in noise?" It turned out the answer to that question was worth more than any gun. The engineers at Telefunken dispersed. Some went to work for Siemens. Others joined Bosch. A few emigrated to America, where they helped build the post-war electronics industry. Hauptmann himself lived until 1967, teaching at the Technical University of Berlin. His students remembered him as a gentle man who spoke rarely about the war, but who insisted, again and again, on one principle: build what works, not what impresses, and build enough of it. The factories that had produced the radios transformed as well. The Chrysler Detroit tank arsenal continued building tanks through the Korean War, then transitioned to other military vehicles. By the 1990s, it had produced over 60,000 armoured vehicles. Motorola grew into one of the world's largest electronics companies, its roots forever tied to those first FM radios built in a Chicago laboratory. The assembly lines that had stamped out tank radios now produced cell phones, walkie-talkies, and satellite equipment. But the greatest legacy of the SCR 508 was not technological. It was philosophical. It taught a generation of military planners that logistics mattered more than heroics. That industrial capacity was a weapon as powerful as any bomb. That the nation which could produce the most would defeat the nation which could fight the best. It was a lesson written in the silence between German tanks and the clarity of American transmissions. In 2003, the US Army opened a small museum at the former site of the Detroit Arsenal. Among the exhibits was a restored Sherman tank, and inside it, still functional after 60 years, was an SCR 508 radio. Visitors could put on the headset and hear a recording of actual tank communications from Inicartia, 1944. The voices were calm, professional, coordinating movements across a battlefield in Normandy. Red 2, advance 50 meters. Red 3, cover the left flank. Red 4, report enemy position. The simplicity was striking. No drama, no panic, just clear, precise communication that had allowed 5 men in separate machines to fight as one. An elderly veteran, visiting the museum with his grandson, stood listening to the recording for a long time. Finally, he took off the headset and said quietly, "That's what saved us. Not the armor, not the gun, that." He pointed to the radio, being able to talk to each other when everything was falling apart. His grandson asked if he'd been scared. The veteran smiled. "Every day, but I was never alone. I could hear my brothers. I could hear my commander. Even in the worst moments, I knew someone was there, listening, ready to help. The Germans didn't have that, and that's why they lost." It was as simple and as profound as that. In the chaos of war, connection was survival, isolation was death, and the side that understood that first had won before the first shot was ever fired. As the sun sets on this story, we return to that moment in March 1943, when Hauptmann Friedrich Weiss first climbed into that destroyed Sherman in Tunisia and found the radio that would change everything. He could not have known, as he brushed away the debris and examined that blackened chassis, that he was holding the future in his hands. That the device he was looking at represented not just a technological achievement, but an industrial revolution. That Germany had already lost the war, lost it in the factories of Detroit, in the laboratories of Chicago, in the invisible waves that connected an army too vast and too coordinated to defeat. The war was not won by heroes, though there were many. It was not won by brilliant tactics, though there were some. It was won by ordinary people, building ordinary things, in extraordinary numbers. It was won by the factory worker in Michigan, installing radios at 3 in the morning. By the engineer in Chicago, testing crystals until they were perfect. By the soldier in France, speaking clearly into a microphone while chaos raged around him. It was won by all of them, connected by invisible threads of electromagnetic radiation, speaking the language of coordination. And when the guns fell silent and the smoke cleared, what remained was not just victory, but understanding. The understanding that modern war is not about who fights hardest, but about who works together best. That clarity defeats volume. That connection defeats strength. That 10,000 adequate voices, speaking as one, will always overcome 100 perfect machines fighting alone. Thank you for watching. For more detailed historical breakdowns, check out the other videos on your screen now, and don't forget to subscribe.